Welcome to the Pure Infrastructure Podcast. It's a podcast hosted by VMware and Pure Infrastructure Limited. The Pure Infrastructure Podcast basically chronicles the journey of CIOs in the East African region. Pure Infrastructure Limited is a managed services provider that helps companies figure out their journey to the cloud. VMware is a leading provider of virtualization and data center technologies, but has moved on to multi-cloud and software as a service in general. Today's guest is a repeat guest. It's Tom Makau, who's the lead consultant at Scipio Systems. We are going to be discussing building resilient networks. Partly, the topic was motivated by the recent Facebook outage, and many people were wondering what was going on. And so I was asked the question a number of times, and I kept saying, I'm not an expert in the space. And so I figured I'd just get somebody who's been in the space for the last 15 plus years to just give us a sense of what was going on. So Tom, welcome.
Thank you. And it's glad to be back again to the podcast. And as you've rightly said, this week we witnessed something major where there was a total outage of the Facebook network. And by Facebook, we mean the network that hosts Facebook, the social media platform, Instagram, and WhatsApp, together with other services that Facebook provides. Yeah. So I think as most people had thought initially that it could have been the work of a hacker, Facebook later came out and said that it was a network issue that led to the downtime. And the problem that occurred was that the way they run their networks is in such a way that they frequently carry out updates on the network. One thing you need to realize that Facebook, other than just providing the platform, is also heavily involved in as far as setting up networks and data centers. And by networks, we mean both local and international networks. So what had happened is that Facebook's network engineering team ended up carrying out an update that affected the network and brought the network down. And that, of course, led to a cascade of events, which to some observers worsened the situation and brought to fore the challenges that network operators face. And basically, the challenge is that however resilient you build your networks, there will always be a point of failure that was unforeseen. Yeah.
Black swan failure, so to speak.
Yeah. So in the case of Facebook, they use the BGP protocol to exchange information, routing information together with other internetworks. Yeah. So Facebook, being part of the network that forms the internet, needs to exchange routing information or reachability information with other networks. And if other networks do not have a route map, so to speak, of how to get to Facebook services, then the Facebook network, the Facebook service will be down for most of the users. So if a user seated in Nairobi, for example, and is connected to a local ISP, the local ISP has within its own infrastructure a route or an instruction of where to take the Facebook traffic to. And this route is always updated by Facebook themselves in terms of what are known as network metric updates. In this situation, Facebook network was down, and therefore the other networks outside Facebook that connect to it were unable to reach it. Now, that was the first problem. But the problem that exacerbated the situation was caused by DNS. If you look at the way Facebook has hosted its domain names, for example, facebook.com, that's a domain name, and fb.com. Facebook itself is authoritative for its own domains, in that the domain name system servers that know the answer to translate facebook.com to an IP address reside on the same Facebook network. And the challenge is with most of the traffic globally today being social media, a huge percentage of traffic flowing globally is social media on Facebook and all that. And with that, it means that majority of the DNS requests that are received even by ISPs, let's say in Kenya, a huge chunk of it is to Facebook. And if you have an ISP in Kenya that has a DNS server that is providing services to its users, mobile users, home users, and enterprise users, it is always, the DNS for this local ISP is always speaking to the Facebook DNS in terms of getting what are known as name resolutions. Now, in instances where this local ISP's DNS is unable to get an answer from the Facebook server, it will definitely send that request again. So what had happened is that because the Facebook network was down and all the other international networks sending DNS requests to the Facebook servers were resending that message frequently, there was now a tsunami of DNS requests again hitting the Facebook servers. So the Facebook engineering team estimates that traffic shot up 30 times. Yeah. So that is happening at the Facebook level. It is also happening at the local ISP level, where devices, your mobile phone, my tablet, and my laptop and all that, because the page has timed out, it will frequently send that query again and again to your local ISP. So the situation was that Facebook network was down, and because majority of the internet DNS servers process a lot of Facebook name resolution requests, they were also affected by their own customers. And you had reports of people saying some parts of the internet are also down. That wasn't because of directly the Facebook network being down, but because the DNS servers that are supposed to process these requests to other networks were also overwhelmed by these repetitive requests. So it cascaded from just a simple network outage to what you'd call an unintended DDoS, where every device on the internet that has the Facebook app or the Instagram or WhatsApp was constantly bombarding their immediate DNS with these requests and overloading that network in that effect. So it took time for Facebook to resolve the issue because, number one, the process that led to the outage meant that they could only do this while on site, because the tools that they use to manage the network remotely inadvertently also depended on these domain names, on these domain name servers that were unavailable at this time. So if an engineer has a URL like consolemanagement.fb.com, where he's supposed to manage, I'm not saying that is the URL, but for example, the resolution of fb.com itself needed to be resolved by a service that is in the network that is down. So it came full circle. So they had to get to the data center. Getting to the data center, it is not easy for these hyperscale data centers. It might take even 30 minutes to 1 hour to get clearance to get into the IT equipment room. So that also delayed the resolution. And it led to a 6-hour outage, which was unfortunate because if you look at it from the number of businesses that depend on the Facebook network or the Facebook services, especially SMEs, they are greatly impacted by that downtime.
Okay. And so what, the thing is, like, you've mentioned a few things, and maybe you could just touch on them slightly. Firstly, what could they have done differently to avoid this situation? Because it seems that what they've done is akin to, they hosted everything themselves and put themselves in a situation where if there's ever one failure, everything else is necessarily affected. So what could dispersing this, what are the advantages of building an integrated stack like they have? And what are the disadvantages of doing the same?
I think before I answer that, we need to look at why Facebook found itself in that situation.
Okay.
With the rapid growth of the social media platform, Facebook found itself expanding its data center services and needed to serve more and more people as fast as they can. And they got to a situation where the equipment they were buying from manufacturers or OEMs wasn't coming to them fast enough and wasn't performing to the expectations. What do I mean by that? Today, if you buy, let's say a switch that you want to put in your data center from one of these large OEMs like Cisco or Juniper or the likes, this switch is designed to serve as many needs as possible for the market, so that you have a switch model X which can do 50 things. Yeah, and to do these 50 things, it needs a lot of memory, it needs a lot of compute and all that. Yet, in the data center that Facebook or any other provider is running, maybe out of the 50 things that this switch can do, they only need like 10. Yeah, so they were paying for capability that they were not using within their infrastructure. So some years ago, Facebook thought about it and decided to set up what is known as the Open Network Project, Open Compute Project. And in the Open Compute Project, what they were saying is that we want to make equipment that will do exactly what we want it to do. And in the process of making this, we'll avail this knowledge that we are gaining from our R&D to the wider public. And now there's the Open Compute Project has several members led by Facebook. So this enabled Facebook to not only decide what should run on the switches that they buy, but they made the switches themselves and went ahead and now they even do things to do with the racks within the data center, storage and all that. So what was happening is that Facebook was now moving across the value chain. Whereas they were playing in one area of providing a certain type of service, and depending on upstream and downstream partners to supply the hardware, to supply connectivity, to supply data center facilities, what Facebook ended up doing is that they were now manufacturing their own equipment and putting a lot of R&D into it in terms of making sure that the equipment is efficient enough. I'll give you an example. In the Facebook data center, like if you look at the US system where they use 110 volts, while the UK system uses 240 volts. Yeah, those two were decided because of characteristics of the filament of a light bulb. The 110 and the 240 were decisions made based on the material that was being used at that time to make the filament of an incandescent bulb. Yeah. And that is the standard today. But when you look at computing, through Facebook research, they found out that it's not efficient to do 110 or 240. So they came to a value which is 277 volts. At 277 volts, running your data center at 277 volts, it is more energy efficient than running it at the standard out-of-socket voltage. Mm-hmm. That is one area. They also not just worked on the hardware and efficiency of data centers. They also looked at utilization of resources in data centers. It's through Facebook that some of these inventions or utilizations of data center capacity have been perfected. Most people would intuitively think that if you have a cluster of 10 servers and you have workload that can be served by 3 of the 10 servers, then you let the 3 servers do the work and let the other remaining servers be idle. If you look at it carefully and look at the power consumption dynamics of that setup, it it is inefficient to have a server operating at idle than operating at medium load. So what they discovered is a mechanism of making sure that they spread the workload received by a cluster across the whole cluster at medium load. That ends up saving them in terms of energy consumption than just having 3 servers doing all the work because of that, and bringing in a 4th server when the workload crosses the threshold for 3 servers. So all that is from within Facebook's internal research. And they've gone a step further now, not just within the data center, they're now moved out. We are seeing partnerships between Facebook and other players when it comes to international undersea cables. There are many projects like the To Africa cable, which is built to be the largest subsea cable to land in the continent. And many other cables globally that are either wholly owned by Facebook or used or leased on long term by them for their own private traffic. So that has had an effect of consumers of Facebook services being served by Facebook across the entire value chain, from the data center, and not just from the data center, from the hardware within the data center is made by Facebook. The racks within the data center, the networking equipment and everything within the data center is made by Facebook. Coming out of the data center itself is run by Facebook and even the systems. The international networks that connect these various data centers globally to each other is essentially a private network owned by Facebook, up to the point where the ISP, the local ISP, peers with Facebook. Everything behind that is virtually within Facebook's grip. So people might be worried, like, why are they doing that? It's not the first time that a company is doing that. If you look at Ford, for example, Ford was making cars, but they moved up the value chain to start producing steel. Yeah. And it's because it was to their benefit to do that, to be able to control the supply chain in terms of pricing, in terms of delivery, in terms of quality. So that's what Facebook has been doing. Unfortunately, that comes with its own disadvantages, as we saw on Monday during the downtime. That everything that Facebook provides to the market runs within their own network. So a question would be like, why didn't Facebook, for example, have the domain fb.com have a different authoritative server other than one within Facebook? That's something to think about. And many other things. Why does the facebook.com domain have the TTL that it has, to the point that every other DNS that caches the response keeps it for about 5 minutes? Why is it not longer? So these are questions that come in when you start looking at how can these networks be made more resilient. And the answer is not very straightforward, because at the altar of resilience, the element of flexibility also gets sacrificed. Because yes, we can create a very resilient network, but it won't be as flexible as we want it to be. And it is in the interest of a player such as Facebook to have a service that is resilient, that can respond quick to failures, and that can automatically identify problems and circumvent them and get them fixed automatically. So it's a balancing act between creating very resilient networks and having the same networks become nimble enough for any changes that might occur.
That's interesting. So the next question, obviously, will be how we can build such resilient networks in Africa, and what your experience has been. But before we jump into that, we'll take a break for a word from our sponsors.
The Australian Securities Exchange is replacing the clearing and settlement solution underpinning the entire Australian equity market with a modern platform based on VMware blockchain and DAML smart contracts. We believe that the combination of digital asset and VMware blockchain's expertise in smart contracts and distributed ledger technology, coupled with VMware's heritage and capability in delivering mission-critical enterprise-grade software and solutions, is the right partnership to assist us in modernising and transforming Australia's financial market infrastructure.
Welcome back to the Pure Infrastructure Podcast, where we are interviewing Tom Makau, who's the lead consultant at Scipio Systems. So we were talking about like the resilience around Facebook and how they built their network, and basically the trade-off they made between ease of managing the network and the infrastructure, and basically what happens when there's a failure. So you've been in the space for a while, and you've built fiber networks, satellite networks, you've seen the entire smorgasbord of networks. What have you seen African providers and Kenyan providers in particular do, and what do you think they can do better, and why do they make the decisions they make around network infrastructure?
Okay, that's
it's like a loaded question.
Yeah, that's quite a loaded question, but I'll try approach it from a historical point of view.
Yeah.
The initial networks that connected Africa to the internet were, I would say, they would often carry all the African traffic back to, let's say, Europe or the Americas. Yeah. So one of the biggest things that has happened since the arrival of these large international networks into the continent was the adoption of local internet exchanges, where as much African traffic as possible does not leave the continent, and that most of it is exchanged locally. I'll give you an example. Before exchanges came in, if you were with ISP A on Mombasa Road, for example, and I am on ISP B in let's say in CBD, and you send me an email, that email had to leave the continent to maybe where your ISP terminates its traffic, which is maybe Europe. Yeah, and they would exchange traffic there with my upstream ISP, and bring that traffic back again to me, who's seated in CBD. So your email essentially left the country, left the continent, and then came back to me, yet we are in the same city. So that proved very inefficient, and also the quality of service wasn't that good. So the first thing that is commendable that African networks did is the establishment of local internet exchanges. That's actually a major win. And this, of course, took the effort of ISP associations. Like in Kenya, you look at the TESPOC, played a very key role in establishing KXP, where the local ISPs are exchanging traffic without leaving the continent. Local traffic stays local. And this is happening in many countries. There are also large exchanges that have come up in South Africa. We have the Napa exchange, and in Djibouti, in Cairo, and all those places. So what these exchanges do is try to create an efficient way in which networks within Africa communicate and exchange traffic. The second thing, of course, is infrastructure. The setup of infrastructure in the continent has often been initially it was satellite based, which in the grand scheme of things, most of it ended up in international networks anyway before coming back. So it is still the same story. So the creation of local terrestrial networks, or the setup of local satellite hubs, enabled, from an infrastructure point of view, local networks to exchange traffic more efficiently. Yeah. Today, if Kenya, for example, is exchanging traffic with Tanzania, more often than not, that traffic will pass via the Namanga route to get to Tanzania, which is a shorter and lower latency route compared to if the traffic left Nairobi, went to Mombasa, went to the undersea cable, maybe went to Europe or the Middle East, and then back to Tanzania. So that interconnection within Africa is happening, There's a lot of work happening by major carriers such as Liquid to try and interconnect the continent east to west, north to south, which will bring in a lot of value in as far as improving the quality of service is concerned. When it comes to the resilience of the network service, you cannot get a very resilient network service if at the infrastructure level is also not as resiliently built. Though there are ways to go around it to ensure network resiliency with a lot of fiber cuts, for example, in the continent due to various reasons. More often than not, critical links are disrupted. And to establish that level of resiliency where an ISP is able to continue providing services to its customers despite the severance of a critical link, there are many things that come into play, and at several layers. The first layer would be at the regulatory level, where the regulators are encouraging infrastructure sharing. So that if I am carrying my traffic to, let's say, to a data center, I am at liberty and I can get very good competitive pricing from my competitor to also carry part of my traffic on their network. That's one. Infrastructure sharing also comes in play in terms of passive components like at a base station or at a telco house, sharing cabinets and all that. From a policy level, then there is at the commercial level where it might make sense for provider to get capacity from its competitor as opposed to building their own network. And if I can get capacity from 3 of my competitors to achieve what I would have achieved had I built my own network, then it improves my resilience because now I have 3 routes as opposed to 1 that I own. Yeah. So from a commercial/technical point of view, there is that aspect. And then also from the user experience point of view, it is in my interest as an ISP to ensure that my customers get the best value in terms of quality of service by taking them where they want to go as fast as possible. I might not have the infrastructure or the capacity to do that, but by designing my network in such a way that I'm able to exchange traffic with routes or with peers that can guarantee me and my customers that service, then it really helps. I'll give you an example. Today, if you look at a wireless ISP that serves, let's say, a certain part of Nairobi, these small wireless ISPs that serve estates, they would often have a large part of their clientele made up of home users. And majority of the home use traffic is social media, Facebook, Instagram, TikTok, and video like YouTube and Netflix. If you look at the traffic profile, about 70% of the traffic is made up of that, with about just 30% actually being traffic that is enterprisey in nature. Yeah, let me use that word. So this ISP is now able to give a better quality of service because with the availability of local caching by these players, YouTube caching their services in Nairobi, Facebook caching their services in Mombasa. As a local ISP, wireless ISP, all I need to do is peer with them directly. And they are allowing free peering. I don't have to pay per se, or I pay a very small fraction of the capability to peer as opposed to buying that bandwidth. So that makes my users' experience of these services much better than the traditional way. Yeah. So the local peering and exchanging of traffic has really helped in improving network performance, and also it has helped in improving resilience of services because in peering with, for example, Facebook in this case, I would definitely be peering with them from a data center that they're located. So that reduces or diminishes the chances that there could be a fiber cable going to where Facebook is that could be down due to one reason or the other. So that has really helped. And the growth of data centers within the continent has really helped that, because now that we have world-class data centers, Tier 3 and the likes, that provide the uptime that these players are looking for, it is now possible for them to come in and host this content locally. And that, again, improves the resilience, because now you do not have all users going to TikTok on a single cable going to Mombasa. Yeah, it's spread across. Some are getting into the data center via ISP1, some are getting via the other ISP and all that. So that has helped. The other thing that I think now local ISPs need to work on is when it comes to capacity. In as much as all this is happening, there are some capacity constraints as far as bandwidth is concerned. You'll realize that it's only in the last 2 years or so that we've had some of our networks backbones being upgraded to anything above 100G. Yeah, most of them were 10 gig. Yeah, and that is actually, if you look at it carefully, that's one of the reasons that has slowed down 4G uptake in the country, 4G rollout, because as a mobile operator, yes, I want to launch 4G in Isiolo. Yeah, but the backbone from Isiolo coming to Nairobi passes through maybe the central region, picks up traffic there as it comes towards Nairobi. 10G will not be sufficient if everyone along the path is on 4G and wants that user experience. So that has been a bottleneck, but that now we are seeing upgrades happening of backbone networks to above 100G. And that is now spurring the growth of technologies such as 4G and now 5G coming. So there is a lot that has been done, but there is still a lot to be done in as far as capacity is concerned. My biggest fear of the networks that we have in the continent or in the country is capacity bottlenecks. Okay.
So that leads me to that sort of two questions I wanted to ask. I think let me just start with the first one. So, there was a lot of noise earlier in the year about Safaricom capping how much you could transfer in a link. And many ISPs have had fair use policies for a very long time, but they're very quiet about it.
Yeah.
And one of the things that I felt was not very clear is how much does it actually cost to roll out these services? Because if people are reticent to make the investments instead of backbone upgrades, is it because they are greedy or is it because it costs a lot of money?
Let me first go to the first item that you mentioned about fair use policy. Now, a network is a shared resource that all the users share. And by shared resource, most people only think in terms of bandwidth. That, so my 10 Mbps that I'm buying from you is shared. It's a shared resource from a bandwidth point of view and also from a compute point of view. That router or that switch that is seated somewhere giving you your 10 Mbps and my 10 Mbps, or whatever Mbps we bought, is a finite device. It has finite CPU, finite RAM, finite number of sessions it can handle, and all that plays into the quality of service that I enjoy. And if you have instances where a user ends up hogging most of those resources, then it becomes unfair to the other user. You might have one user taking up 50% of the resources that have been allocated to 10 users. Yeah. So the other 9 users are getting a very bad experience, and it's not in the interest of this provider to have that situation happen. So fair use policy is not really more about capping your usage, but about striking a balance between how much investment we should do in a network vis-a-vis what we are getting out of it in as far as revenues, and sustain these revenues or grow them by making sure that the quality of service that we are giving these users is not compromised. Yeah. So you can have a user on 2 Mbps link causing a lot of havoc on the network. Not because he's using more than 2 Mbps, but because within that 2 Mbps, he has over 3,000 sessions going on, maybe for BitTorrent, just as an example. So these 3,000 sessions on this 2 Mbps link actually being handled by a device on one end. This device has to utilize memory, it has to utilize CPU to serve this user for what they're doing. So fair use policy comes into play to ensure that at no given time, a user uses the service in such a way that it compromises the quality of service of the other user. It's a collective effort. It's a collective utility that needs to be managed well. And maybe it's the way it's been interpreted, that if I've paid you for a 10 Mbps link, I expect to do 10 Mbps at any given time. Yeah. But unfortunately, we carried over what I would call as legacy parameters of defining networks from the voice era into the internet era, where the quality of a voice call was determined by the bandwidth you gave it, and maybe the sampling rate, if you're converting it into digital. Yeah? Okay. So if you use a higher sampling rate, you need a higher bandwidth to transmit that voice call. If you use lower sampling rate, you need less bandwidth. Yeah. So by default, most copper lines were 64 kbps. Yeah. Yeah. And that was like the default internet link that you'd buy when internet came, 64 kbps. So we carried that definition across to data services, where we define the quality, we define the quality or the quantity of service we give a customer based on bandwidth. It is like defining the amount of water you need to pay, the water bill that you need to pay based on the diameter of your pipe that comes to your house. Yet, your water bill is based on the liters or meters cube of water consumed in a month. Yeah. It's not based on how wide your pipe is. Yeah? It is how much water you've consumed that you pay for. So that is the approach that ISPs need to look at. And it comes into play especially when you're dealing with wireless networks, where the wireless spectrum, based on the technology you're using, can only carry so much. And if you're not careful, you might end up providing very poor quality of service because you're not reining in these occasional users who end up destroying the service for everyone because they are hogging up resources. Yeah. They would maybe stick on a frequency for too long, or maybe transmit at a much higher power than required, therefore drowning out the others. There's so many factors that come into play. And many things that are done by a provider. For example, there was a time that people were wondering, why are the mobile operators after Chinese phones? Yet those are the devices we can afford. Yeah, it's because initially at that time, things have changed now. At that time, majority of the devices that were of Chinese origin were poorly designed in terms of how they interact with the base station, in terms of how much power they transmit to the base station and all that. So there was a lot, and there was also the element of the fact that you could easily change the IMEI number from those phones and all that. So you could have a phone with Chinese characters on it as the brand name, but when you check the IMEI, it belongs to a Nokia phone. So it brought all those sorts of problems. But at the end of the day, the operator is after ensuring that the quality of service that they're giving to everyone on the network remains at a level where they can sustain their revenues and get more customers coming in to use this service. And it's a very fine balance between spending a lot of money to ensure a certain type or level of service vis-a-vis trying to balance out the needs for all these users that are on your network. So the second question...
No, the first was just generally on the fair, and then the second one was how expensive is it to actually roll out these networks?
Yes. Now, by expense, you need to realize that when you're rolling out, let's say, a fiber network, there's a lot of supporting infrastructure that needs to go with it. Everything, including the roads that these field technicians need to take when going to lay this cable, the availability of electricity, availability of resources within the country, and all that. So it is expensive to roll out infrastructure in the continent. And if you look around, only the very large players who have access to good funding, sources of funding, are able to roll out large-scale projects in the continent as far as connectivity is concerned. And there are several of them in the market. But that's changing, and it's changing from the perspective that there is a realization that for the African IT space to grow, we must invest in the infrastructure. Yeah. And before any provider wants to play at the services level, they must make sure that they have invested enough in infrastructure. In the short term, it might look like it's expensive, but in the long time, it pays off. And it's happening. Look around. If you look at Safaricom, they've rolled out an extensive 4G, 3G network across the country. They've rolled out fiber. And now, after that, it is now when they are looking at ways of monetizing that infrastructure. You opening your phone and opening up the little cab app to get a cab or to order some food delivery is actually them utilizing the infrastructure that they've laid. You see, they do not now have to come and sell you a pipe to the internet. They are now selling you a service on top of that. And them doing enterprise network services, enterprise IT services, digital transformation, is all because they have the infrastructure. The same thing even with the players like Liquid Telecom, who are now Liquid Intelligent Technologies. They have done enough in as far as laying the foundational infrastructure. Now, the story of selling you capacity no longer makes business sense as such. So they need to move up the scale to offer you services. And that is what they're doing now. So it is important that ISPs or telcos lay infrastructure, but it should not be laid with the mind of recouping the return on investment purely on selling the network service itself, but building services on top of it. And if you look at it that way, then there is incentive to build these networks with the knowledge that what you are riding on is not selling capacity or fractions of this network to users, but selling services on top of that.
So it's quite similar to how basically Safaricom rolled out a 2G network and M-Pesa basically rode on top of it.
Exactly.
Okay.
Yeah.
Finally, like you said that the networks here evolved in a different way. Mm-hmm. How did networks in other parts of the world evolve?
I think there's always this story of Africa having leapfrogged the copper lines and moved straight into mobile. That's a feel-good story to tell, but it had its downsides in terms of the infrastructure that was needed initially to offer these copper networks was largely absent in Africa. So when you talk of extending terrestrial networks to areas that had never even had copper, there are challenges that come with that in terms of availability of wayleaves, for example, people's understanding of what this service is. Yeah. One reason why there are outages in Africa due to network cable cuts is because people do not understand the significance of that cable that was dug across your land by some guys who came here in luminous suits and helmets. Yeah. They don't make the connection between the M-Pesa message they receive or the WhatsApp message they receive from their loved one to that cable passing under there. Yeah. So next time he's making bricks, he'll dig the same place and start making bricks and ending up cutting out communication. So there is that aspect that we never had the advantage of having these legacy networks that people understood their value, and we jumped straight into where we are currently. There is a lot of work to be done in as far as rolling out network infrastructure in Africa. A lot has been done, and there is talk of leapfrogging again from 3G to 5G. That's still up for debate. But the revolution that is going to come, or the revolution that is coming, is pegged on wireless networks. Okay. Be they 5G, be they low Earth orbit satellites, be they the now failed Google Loon. There are many others that will come like that. This is just the beginning. If you compare to other countries where the foundational infrastructure was there, if you wanted to lay a cable from city A to B, you do not need to do actual physical trenching, digging an actual trench all the way. Conduits already exist under the roads. It's easier for an ISP to lay its cable because the structures are there, the infrastructure is shared, maybe owned by the municipality or owned by a common player who then sells this service to everyone. So we are not there yet. Then the other thing I think that is working to our disadvantage is our licensing regimes. It is very easy and to set up a network within a country. But when it comes to creating an Africa-wide network, there are so many things that come into play. One is the licensing. There are needs for us to advance as fast as we want. We need to relook at how our telco ISP licensing regimes across Africa works. There's need to harmonize. It should be easy for an ISP in Tanzania to roll out infrastructure in South Sudan or Kenya or Mozambique. It should be easy for an ISP in Uganda to come roll out infrastructure here. But our licensing structure currently does not favor that. Yeah. So, whereas if you look at the United States, it's a different story from a federal point of view. If you look at the European Union, it's a different story. It's easy for Deutsche Telekom to go lay out or set up infrastructure in another European country than it is, for example, for an operator in Kenya to go lay out infrastructure in Somalia or Tanzania. Yes. So licensing is something that I think is the regulatory framework basically needs to be harmonized to ensure that it makes it easier. Yeah. Yeah.
Okay. So if I get you straight like that, just to paraphrase it, the legacy networks basically provided a framework that modern ISPs could use. So it's cheaper for them to roll out than it is for Kenyan or African ISPs for that matter. Because we have to start by building the ducts themselves, which is where most of the cost is in the build out. Yes. And secondly, just we have a very fragmented regulatory framework. So it's not easy for you to build a network with one standard, knowing that the next country will have a similar standard. So you can just find completely different policy environment.
And that plays also into the quality of service. Eh? Yeah. You have instances where an ISP is serving, let's say, a global client with branches across, let's say, several countries in Africa. But to get into some countries, this ISP runs a very good network, reliable, but at the handover point getting into country X, you need to hand over to the government incumbent, whose quality of service is not guaranteed, whose operational procedures and processes are not top-notch. So again, you end up not delivering the QoS you promised your customer across the continent because of such things. This protectionist kind of regulations need to be reviewed as fast as possible. And we need to also take advantage. The other thing that we can do very well in Africa is take advantage of our existing or currently being set up power infrastructure network. I'll give you an example. In Kenya, for example, Ketraco and Kenya Power are members of what is known as the Eastern Africa Power Pool. Yeah, in that they can buy and exchange power across them. And the effect of them being members of the East Africa Power Pool means they're interconnected across all these countries in as far as power lines is concerned, and also in as far as fiber optic networks are concerned. Because remember, most of these power infrastructure has a fiber optic, what is known as the OPGW, which is the fiber optic link that is used for monitoring the network itself. And there's also excess capacity that can be used for commercial use and data, transmitting of data traffic. So that gives an opportunity for players across Africa to set up a resilient network very easily. And I believe that's one, I would say, low-hanging fruit. So if an ISP here needs to connect to DRC, instead of thinking of putting that investment first under the ground through digging of trenching all the way, does any of these players in the power space have capacity or fiber capacity to DRC or somewhere near from where we can build on? So there is that. We can take advantage of that. And the railway lines that we are building around can easily be done with the fiber optic cabling inbuilt to transmit data across all those regions. Remember our initial, if you look at the initial railway lines in Africa, they were mostly built from an extractive point of view. They were all starting somewhere and ending at the coast. Yeah. If you look at the original map, it starts from Kisumu, ends in Mombasa. Starts somewhere in Tanzania, ends at the port in Dar es Salaam or somewhere. So that didn't help much because the initial use of that railway line was for extractive purposes more. Yeah. But with the new railway being set up, there are plans to interconnect the Kenyan SGR to the Ugandan one, and so on and so forth. There are plans to do pipelines across from the oil fields in Tanzania, in Uganda, in Kenya. Those pipelines will come with fiber optic networks. We need to plan around that and utilize that. Yeah. There's no reason why large swaths of South Sudan should be in the dark as far as internet is concerned, because they rely mostly on satellite. Yet they have pipelines running all the way to the Red Sea. That have capacity that can be utilized. I think it took Liquid taking cable there for them to be on off satellite internet. So those are things that we need to look at. In short, this play is not going to be a private sector only play. It has to involve the government and semi-government organizations like oil pipeline companies, power transmission companies, which are mostly government or semi-government owned. It has to involve the private sector, It has to involve financiers. Because if I'm a financier financing a pipeline, and I'm also thinking of financing a fiber cable to a private player, I could easily combine these two into one project and achieve the same results at a much lower cost. Yeah. And at the end of the day, this cost benefits end up benefiting the consumer. Yeah. So it's a multi-pronged approach from both private sector. Private sector cannot do it on its own. Yeah. They might have the money, but they might not have the goodwill. Yeah. Or the diplomacy required to make it work, especially across countries. Yeah. Government might have the goodwill and the links to make it work, but they might not have the money or the operational capacity to run those networks and so on and so forth. Yeah. So we've made a lot of progress as Africa in as far as building a resilient networks is concerned. Yeah. And this is purely from a physical point of view. Yeah. When it comes to the service level, there's the resilience from a physical point of view and also from a service level point of view. The need to exchange traffic locally cannot be overemphasized. Yeah. The need to create local internet exchanges. Yeah. There's absolutely no reason why my traffic from Nairobi to Central Africa Republic should go around the continent. Yeah. 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 There's absolutely no reason why my email from Nairobi going to DRC, Kinshasa, should go around the continent. Yeah. 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 Once we build resilient networks within the continent, we'll see a lot of things. There'll be an explosion of use cases for these networks and the services that will be built on top. Yeah. Remember, a service like Uber or Little Cab could not happen without 4G. Yeah. You couldn't do that on 3G networks. Yeah. Because it wouldn't work. Yeah. And the 3G phones were also not capable of doing that. Yeah. So these services that we are seeing happen, you couldn't order food on an app on the 3G network. Yeah. You only did that from 4G onwards and home internet. So there's going to be a growth of the use of these networks. There's usually the fear that we might invest in these networks and then what happens next. But if you look at it from the point of selling capacity, you'll miss the point. Yeah. But if you look at it from creating a platform from which services can be layered upon, don't create a 4G network to sell to Anjiko as 4G, as fast internet. Yeah. Create a 4G network to enable Anjiko do a boutique business straight from her house without incurring the cost of rent, without incurring all the other risks associated with and the costs associated with starting a small boutique and so on. Yeah. So that's the approach that African operators or network providers need to have. Yeah. Move away from the network and focus on the services. Yeah. And naturally, you'll find yourself expanding the network without a worry about the level of investment that's happening. Okay, so just to sum it up,
work with government, find ways of driving down the cost of rolling out the network, and focus on the services, as that's what will fill up your pipes.
Yes.
Yeah. Thank you so much, Tom, for showing up for this podcast episode.
Thank you.
That's it for the 5th episode of our podcast. We'll be back with an interview with a blockchain expert. See you then.